Hello everyone, welcome back. I know it's been a while since I've made you guys watch a video by me, but this is just a very brief recap. We are going over a lot of stuff in class today, but I know some of you may have missed class, some of you may have not paid attention one day. Whatever the issue is, I'm covering all of the chemistry unit today. So this video is a little bit long, so bear with me. Here we go. So we started off our chemistry unit by talking about atoms. Atoms are those tiny, tiny, tiny particles that make up everything in the universe. So an atom, written A-T-O-M, atom, is made up of three parts. It has protons, electrons, and neutrons. This is where we get our pen chart from. Please, 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 whenever you have any question about atoms, write down your pen chart. That should be your first step. First is the mass, then the location, and then the charge. So the mass, 1, 0, 1. Location, inside, outside, inside the nucleus. The charge, plus, minus, 0. Always, always, always copy this pen chart onto any question about atoms, and that will make your life a lot simpler. So what this tells you is that protons and neutrons have mass and they're inside the nucleus, and electrons are outside the nucleus and have 0 mass. But protons are positive, electrons are negative, and neutrons are neutral or have no charge. Okay, so that's all you gotta know about those three particles. Now, in an atom, the protons, as we said, are inside the nucleus. The neutrons with no charge are also inside the nucleus. They're the same size. I know my drawing's not the same. And then we have the electrons outside the nucleus in the electron cloud on our energy rings. And those are so tiny, we consider them to have 0 mass. When we are drawing our atoms, inside it's easy to just draw the protons and the neutrons depending on the number we have of each, but then the electrons follow a specific rule. On the first ring, we can only fit 2. On the second ring, we can fit up to 8. And on the third ring, we can fit up to 8 as well. The 288 rule, Highway 288, is your reminder. So we can fit up to 2 electrons here, then we have to add another ring. We can fit up to 8 electrons on this one, so 2 plus 8 is a total of 10. If you have more than 10 electrons, you're going to need 3 rings, and this one can fit up to 8. And if it's more than 18, you're going to need a 4th ring, and so on. Okay? So this is basics of the atom. Then we moved on to talk about what these things mean. So number of protons, it's what's going to tell you your identity of the atom. So the number of protons that you have is going to be equal to the atomic number. The atomic number is what gives us the number of the element in the periodic table. Each element has a different atomic number, and so when you change the number of protons, you change the element. Then within the electrons, the ones on the last shell, so if you have 2 shells, let's say this one has 2 electrons there, and another electron on the second ring, so a total of 3 electrons. This last ring is what we call the valence shell, because it's where we have our valence electrons. Valence electrons, the ones on the last shell of the drawing, these tell you the reactivity, how something will react. It's a chemical property, as we learned in our last classes. So it will tell you how it will react. Is it going to explode like the videos we saw or not? Now there's most reactive if you have 1 valence electron, or if you have 7 valence electrons, it's going to be extremely reactive. So this is when you have highly reactive. It's going to go boom, boom. Okay. Any other number in between 1 and 7 will also react, but these are the most reactive. Okay. For it to not react, it has to have a full shell. So if it has 2 on the first one or 8 on any other shell, then it is stable. It will not react. Okay, it's happy there. It does not need to react. These are the only ones that will not react. So here you'll have no reaction. But if it's any other number that's not 8, or for the first one 2, then it will be reactive. And if it's 1 or 7, it's super reactive. Okay, from then we moved on to the periodic table. And in the periodic table, we had a few rules that we followed. So this is a rough sketch of the periodic table. Now, in this periodic table, we have the metals. Side, these are all metals. Everything on the left is a metal, except for hydrogen. That's our only exception. This one belongs over here. On the right side, we have the non-metals. And in between the two, we have a staircase of approximately 7 or 8 elements, I don't remember exactly, that are our metalloids. So our metals are going to be shiny. They're going to be conductors. They can conduce heat, they can conduce electricity. They're going to be malleable, which means you can bend them and shape them however you want. Okay, and they're ductile, which means we can make them into wires. Okay. Ductile, not ductilely. Our non-metals are going to be the opposite. They're going to be dull, so they're not going to shine. They're going to not conduce electricity, so they're going to be insulators. They're going to be bendable, so they're going to break, which we call brittle. Think of the word break. It starts with BR, so does brittle. And that's it for nonmetals. For metalloids, it will have properties of both. So it can have some properties from metals and some properties from nonmetals. So it will have properties of both, and it will be a semiconductor. So it kind of conduces electricity, not completely. Semiconductor. Okay. Now, in our periodic table, each box looks kind of like this. It has a number at the top. That's your atomic number that we talked about earlier. Number of protons. So it's equal to the number of protons, and it's also equal to the number of electrons if it's a regular atom. Okay, then we have the chemical symbol, and then down here we have another number, but this one has decimal points, point something something. So this number on the bottom, that is your mass. The mass, how much stuff it's made out of. So to calculate the mass of an atom, you do protons plus neutrons, and that's the mass. If you want to find the number of neutrons and you know the mass, then you just do the opposite. Mass minus protons equals neutrons. This was mass. Okay, so if you want to find the mass, you add protons and neutrons. If you want to find the neutrons, mass minus protons. Okay, now there's one more thing here. We have these numbers at the top of every column of the periodic table. So you have 1 and 2 over here. 3, 4, 5, 6, 7, 8. So you have your 8 main groups. They're technically 18, but groups 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, below the group number is usually a Roman number with a letter A next to it. That is telling you the number of valence electrons. So if it's in group 1, it's going to have 1 valence electron. Group 2, it's going to have 2 valence electrons. Group 13 is going to have 3 valence electrons. So remember, you can't have more than 8 valence electrons. If you are answering something that is bigger than 8, it's wrong. So 1 and 2 are fine. They're the same as the valence electrons. When you start with 13 through 18, you just take off the 1. So instead of 13 valence electrons, it'll have 3. Instead of 14, it has 4. Group 15 has 5, and so on. So these numbers at the top of the periodic table tell you valence electrons. The numbers on the side for each row, these are the numbers of electron shells. So all the elements in the first row only have 1 ring. All the elements in the second row have 2 rings. All the elements in the third row will have 3 rings, and so on. These are the things we talked about in the first test, and you should be completely familiar with everything here so far. If any of this is confusing, let me know. I'll try my best to help you. You can find all the slides on the hub. So now let's go on to the next stuff that we talked about after our first test. So we started talking about counting the atoms when you make molecules. So a molecule is a group of atoms. It's just 2 or more atoms. Okay, doesn't matter what kind of atoms, as long as there's 2 or more atoms, that is a molecule. So if I have H2, that's a molecule because I have 2 hydrogens. If I have H2O, that's a molecule because I have 2 hydrogens and 1 oxygen, so it's more than 2 atoms, right? So whether it's just 1 element or 2, this is a molecule. Elements are every capital letter. So you get a new element when you add another capital letter. Okay, so the number of elements is the number of capital letters. Capital letters are the big ones. Okay, so if I see HE, that's just 1 element because there's 1 capital letter. If I see H2O, this is 2 elements because I have 2 capital letters. Okay, and when I have combinations of 2 or more capital letters, we call that a compound. So yes, H2 is a molecule, but it's not a compound because it only has 1 capital letter. H2O is a molecule and it's also a compound because it has 2 capital letters. So 2 or more capital letters is a compound. Okay, now we were looking for how to count the number of atoms of each element in a compound. So what we do is if we have something like 4 Na SO4 2, which this would be something like sodium sulfate. This is a formula. A chemical formula is just how we express elements and compounds. 1 second. So this expression of elements and compounds is going to guide us to how many atoms of each element we have. So Na is sodium, so we write that one down. That's our first step. Identify all your different elements. So we have first capital letter, next capital letter is a different element. Next capital letter is a different element, okay? So Na, S, and O are all the different elements we have. Then step number 2, add your ones where you don't have a number. So 1 next to A, 1 next to the S. Okay, now we write those down. Na has 1, S has 1, O has 4. Now this big number is going to multiply everything after it. So times 4, times 4, times 4, give us 4 and 16. Okay, so we left off here. We had our sodium, sulfur, and oxygen are elements. And we added our extra ones where there was no number. So we had 1, sulfur had 1, oxygen had 4. Then this 4 affects everything else, so times 4, times 4, times 4, and we get 4, 4, 16. And then this, we have to look at the parentheses, but this little number is only going to affect the ones inside the parentheses, which in this case are oxygen and sulfur. So only those two will get multiplied. So times 2, that gives us 4, 8, and 32. And if I asked you about the total number of atoms, whenever you see that word total, all you have to do is add them together. So 4 plus 8 plus 32, which gives us 44 total atoms. And that's it. That's counting atoms. So now we look at a chemical equation. So chemical equations are when we have a bunch of formulas put together. So what if I have 2H2, that's one formula, plus O2. Goodness. That's another formula. That's going to give me H2O. So remember, reactants are before the arrow, products are after the arrow. So if I ask you about the reactants, it's about these two. If I ask you about the products, it's about this one. So underneath our arrow, let's write down our elements like we did for counting atoms. Hydrogen, oxygen. Those are the only 2 capital letters we have. If they repeat, don't write them twice, just add together. But we don't add the reactants and the product side. Each side is separate. So on the reactant side, I have a 2 hydrogen and a big 2, so 2 times 2 is 4. Oxygen does not have a big number, so we place our imaginary 1. 2 times 1, 2. On the other side, we have imaginary 1, imaginary 1. Hydrogen is 2 times 1, gas is 2. 1 times 1 equals 1. Now, when this is what we're looking at, we see that hydrogen before and after is different. That tells us this is an unbalanced equation. It cannot happen because the law of conservation of mass tells us that we cannot create or destroy matter. So we would still need those 4 hydrogens to be somewhere, right? We're missing 2, so this is not possible. So what if I have this equation? I have 2H2 plus O2, so the same reactants. But now what if I say that that gave me 2H2O? So now I'm looking at the product side again. And for hydrogen, we have 2 times 2 is 4. And for oxygen, 1 times 2 is 2. So now this is the same as the reactants, and this is the same as the reactants. So now this equation is balanced. That means this one can happen. We can do this because we're not creating or destroying any atoms. It is a balanced equation. Okay, that's all you need to know about chemical equations. Now, chemical equations are the math representation of chemical reactions. For chemical reactions, we have 5 main indicators. Remember, city girls like to party. These are the 5 main clues that we had a chemical reaction happen. And the chemical equations we just studied are the math form of a chemical reaction. So C stands for color change. Remember, this has to be unexpected. So if you mix blue and red, you expect to get purple. And if you get orange instead, that's an unexpected color change. That's a chemical reaction. If we have gas appear out of nowhere, like a cloud of smoke, we know that was a chemical reaction. Sometimes the gas, though, is not that obvious. You just have little bubbles. That's an example of gas, and that is also a chemical reaction. Light, so if you have an explosion and you see light come out of a reaction, that is a chemical reaction. Temperature, just like with color, it has to be unexpected. If you add heat, that's not unexpected. You expect for it to get hot, right? But if you just mix 2 room temperature liquids and then it gets really, really hot without you adding any heat, that is a chemical reaction. And lastly, precipitate. Precipitate just means that a solid appeared where there was no solid there before. Precipitate. So if you mix 2 liquids and you get a powder at the bottom, or you get crystals forming, which are solids, that is a form of precipitate. That is a chemical reaction. And that's it. That's all we've learned so far in like 30-ish minutes. So study up. If you have any questions specifically about any of these topics, go back and look at those slides. Check out those Quizlets for help with vocabulary, and let me know if you have any questions. All right, I'll see you guys tomorrow for your test. Please study. Bye-bye.